Hello everyone and good morning. I would like to welcome you to today's webinar. It's the 7th webinar of 5G-MOBIX, where we will be talking about 5G for connected and automated mobility with a focus on challenges and integration and lessons learned. My name is Fikret Sivrikaya. I'm a Communication and Dissemination Officer with ICCS in Athens, Greece, and today I will be moderating this webinar. Before we get started, I would like to inform you about the process, as you will have the opportunity to ask your questions, to submit your questions to the question box that you can see on your control panel. We will collect those questions and we'll address them towards the end at the Q&A session, which will approximately last for 15 to 20 minutes. If you are experiencing any issues with the audio or you cannot see the presentations, you can use the chat box from the control panel as well to inform the organizers, and they will be taking care of it. And now I will close my camera, and I'm pleased to introduce the speakers of today's webinar. From 5G-MOBIX, we have Fikret Sivrikaya. He is a senior researcher and lecturer at the Technical University of Berlin, as well as a research director of the German-Turkish Advanced Research Center for ICT, which is a nonprofit research organization and affiliated institute of TU Berlin. In 5G-MOBIX, he is leading the 5G corridor rollout coordination, and today he will provide a summary of the vehicle and CAM infrastructure related issues and lessons learned. Then also from the EU project 5G-MOBIX, we have with us Dr. Simon Rommel. He's a PhD holder with extensive academic and research experience in Europe and beyond, also in Japan. Since 2017, he works as an assistant professor in TU Eindhoven in the Netherlands, continuing his work on photonic and radio frequency technologies, with a focus on implementations for 5G. His presentation today will cover 5G network deployment challenges and lessons learned in the 5G-MOBIX project. Next, from 5G Kroko, we have Dirk Hetzer. He is a senior expert for T-systems in different network-oriented projects. He's the technical manager of 5G Kroko, and he's heavily involved in 5G network requirements for many automotive applications and use cases. He has a master's degree in electroengineering and a PhD in computer science. Today, he will provide an insight on lessons learned during the use case test on pilot sites, also giving us a few hints on the evaluation results. Last but certainly not least, we have Edwin Fischer from the EU project 5G Carmen. He's a senior expert for research and innovation at Deutsche Telekom in the area of 5G for connected and automated mobility. He has a professional experience in telecommunications and IT for more than 30 years. He is involved in several EU projects and serves as a technical manager for 5G Carmen. He's the co-editor of the 5G strategic deployment agenda for CAM in Europe, and he's also a vice chair of the 5G for CAM work group in 6GIA with a focus on deployment. Today he talks about 5G CAM deployment in today's 5G NSA networks. Thank you all for being here with us today, and I don't want to take any more of your time, so Fikret, the floor is all yours.
Thank you very much, Sevi. Good morning, everyone. In this opening talk, I will start with a very brief introduction to the project, to the 5G-MOBIX project, and to set the stage for the rest of the panel. And then I will mainly focus on the CAM infrastructure related experiences from our deployment activities so far in the project. Sevi, we can proceed to the first slide, to the next slide. Okay, maybe there's some delay. I just saw it now. 5G-MOBIX, as most of you already know, is actually one of the projects. All these three projects actually are part of the projects that were funded by the EU Horizon 2020 program through this ICT 18 call. This is a very specific call focusing on 5G for connected and automated mobility CAM scenarios in cross-border settings. So this is a quite fairly large project, bringing together 60 partners. And our common objective, also with other projects presented today, is actually to deploy, test, and validate 5G network capabilities for CAM scenarios. And in doing that, we are not only focusing on the technical aspects, but also business and regulatory aspects, standards, etc. And in the next slide, we see some more overview of the deployment, the rollout in 5G-MOBIX. And it's quite a challenge to actually conduct real life end-to-end CAM testing and evaluation, right? We need to bring together many pieces. So this, of course, starts from the 5G network components with various 5G features, but also we need to deploy vehicles, onboard units, roadside infrastructure, edge and cloud resources, and applications to realize the CAM scenarios, and all these should be well integrated. In addition, we need to cover diverse use cases and characteristics of the CAM scenarios. Therefore, we have several sites in 5G-MOBIX trying to collectively cover as many features, 5G features, as many configurations, and as many use cases as we can. Of course, the primary experimentation sites are the cross-border corridors, Spain, Portugal, and Greece, Turkey, in our case. And these are complemented by 4 EU trial sites, Germany, France, Netherlands, and Finland. And these aim to develop, integrate, and conduct the initial testing of certain functions, certain components, which are to be eventually also trialed in the cross-border settings. We have additionally some associated partners, associated projects in China and Korea as well. Next slide, please, Sevi. Okay, still coming up to me at least. Okay. So here's a quick snapshot of what we have deployed at what location in terms of the CAM infrastructure. So these consist of vehicles, onboard units on the vehicles, roadside units, and MEC or edge nodes. On top of this, of course, we need to have cloud resources for applications and also for data collection and also applications to realize the CAM use cases. Our vehicles range from level 2 to, most of them range from level 2 to level 4 autonomy, but we are not restricting ourselves to those. We actually also employ legacy vehicles with the addition of onboard units and 5G connectivity. This is especially a requirement when we do testing in open roads with actual traffic, where we cannot yet do autonomous driving anyway, in many cases. And that's fine because we are in these projects focusing on the 5G network. So it is a CAM setting. It is dealing with many complexities and components in the mobility domain, but our focus is not actually on autonomous driving itself, but on the 5G network capabilities and performance. Right, so as you see, we deploy, besides the vehicles, connected vehicles, also roadside infrastructure, roadside units, edge computation resources. So we can say we are not digitalizing and connecting only the vehicles, but also the infrastructure, the road infrastructure. I won't go into the details, of course, but you are welcome to check out our deliverables, which are published on the website. We can proceed to the next slide. So the overall objective of all those deployments is to assess the impact of cross-border mobility for CAM users' perceived performance. And all those deployments, all those complexity, cost, and effort would be mostly wasted if we did not have a very well organized, systematic approach to measurement and evaluation. So this such a measurement framework and data management approach is crucial aspect for having proper 5G for CAM testing in an end-to-end and usable manner. Arguably, this actually is even more important than all the other deployment components or bringing them ready and complete to the detail. So unless we have a well-defined measurement framework, KPIs, data management platform, we cannot get the insights that we need to get from such deployments. So as a start, we need to have a set of well-defined KPIs. These should cover not only CAM from end user perspective, but also networking KPIs. We need to have measurements at several layers and segments of this end-to-end chain. We need to have common data formats and the tools to support such data collection or transformation into the right format and managing the data. And that is what we aim to have in 5G-MOBIX with a whole work package dedicated to developing and utilizing such tools at the whole consortium level. So the key message here is that there should be a very clear pipeline going from the raw measurement data to the calculated KPIs. We can proceed to the next slide. So we said it's important to manage data, collect data and manage data at several different layers and different levels of granularity. And here on the left diagram, we see the hierarchy of data management in 5G-MOBIX. First of all, each trial site has local facilities to store and manage data, and these are the data coming from individual components at different layers, vehicle, RSI, network, cloud, etc. But we also, from the beginning, adopted a central component, the centralized test server or central test server, the CTS, which is collecting the global data in a common format. So by doing that, by adapting a common data format and by adapting a centralized data management approach, we are able to do automatic KPI computation, so towards this end-to-end pipeline from data to KPI calculations, and to facilitate also cross-site evaluations. In addition, we also intend to expose the data through the CTS to the community and to third parties. Again, for details, we have a deliverable focusing on the evaluation framework and the data management aspects of D3.5 available on the project website. Next slide, please. So to the coming to the main point of lessons learned and best practices, and here I would be focusing mainly on the CAM infrastructure. My colleague Simon will take over next, focusing on the 5G network related experiences and issues. So as said, our focus is indeed on the 5G network at the border crossings, but we still have to deal with many other complexities in deploying CAM components and operating them. So besides the 5G network itself. So here are just some observations based on our vehicle OBU deployment and integration experiences. First of all, the OBU design, the onboard unit design itself, with its hardware and software configurations, could significantly impact the performance measurements that we get, the performance that we achieve for the use cases and for the 5G network. So this calls for agnostic testing to benchmark the OBU before we can draw any conclusions from the specific test cases. Then we need to have accurate synchronization clearly across all involved entities in a use case, including the vehicles and onboard units. This is critical for performance measurements, especially in the CAM domain, because here we are talking about latency requirements in many use cases in the order of milliseconds or tens of milliseconds in many scenarios. Therefore, the synchronization errors, accuracy errors may make a big difference in what measurements we get and what insights we make out of those. Another point which is maybe somewhat clear is that the external antennas make a big difference in vehicle connectivity compared to having indoor antennas, in-vehicle antennas. This may be clear, but this fact may be neglected, especially during the initial testing phases, deployment and testing phases, where one may actually deploy a loosely coupled portable OBU device. It could be even a laptop as an emulated OBU for initial testing in the vehicle. But then we need to keep in mind that the performance that we get with the indoor antennas on those devices would be different than the reality with the external antennas, which is the typical deployment case for connected automated vehicles. Next slide, please, Sevi. So, when it comes to the roadside units, one of the key messages is that the effort of deploying and maintaining such roadside installations should not be underestimated. And here we are not just talking about technological complexity of deploying and maintaining such infrastructure, but also dealing with the physical installations, the official permissions that need to be required, the bureaucracy involved, etc. So one should always aim at keeping these the infrastructure elements, entities, to a possible minimum. Then another observation is that the MEC application development for CAM requires very careful end-to-end integration testing, because there are a diverse set of potential errors in this end-to-end service chain. So it could be due to the infrastructure elements, plus if of software implementations on the MEC layer itself, in the network, in the UE hardware or firmware, and in the application logic on all the elements that are involved. Therefore, a step-by-step and systematic integration testing is quite important. We also believe that there's a lack of standard MEC APIs to manage the service lifecycle of applications, leading to some extra work, especially for migrating or cloning a MEC service to another environment. This is particularly important in a cross-border setting. So ideally, we should have a standardized mechanism to transfer session data among MEC nodes, including MEC nodes that are provided and offered and hosted by different networks, different PLMNs. So the combination of all of these make the development of MEC applications and in general CAM connected and mobility applications quite challenging and require end-to-end engineering skills, especially in cross-national and cross-vendor deployment settings as we are dealing with. With that, yeah, I would like to conclude. In the next slide, I have some extra pointers for further reading, some recent selected publications which partly cover some of the mentioned issues here. So now I can hand over to Simon for the 5G network focused experiences from 5G-MOBIX. Thank you.
Thank you, Fikret. Simon? I think we cannot hear you. I don't know if it's just me.
Maybe now.
Yes, we can hear you now.
Excellent. Sorry, it seems that the mute is not synchronized. Yeah, I'm Simon Rommel. I'm from Eindhoven University of Technology, and I would like to very shortly discuss the challenges and lessons learned that we are taking away from the project in the rollout of our networks at the local trial sites and cross-border corridors, which Fikret already introduced. If we can go to the first slide. Basically, as was said already, we have 2 cross-border corridors and a number of local trial sites, and I don't want to spend much time on this slide. The point that I want to make here is that we have both SA and NSA networks, so we're testing both. How does the network, and especially the transition from one network to the other one, behave in NSA and in SA deployments. We also have the consideration of a multi-SIM application. So basically, if you have 2 SIM cards in your local or your end user device. We also have on the French trial side some satellite network integration considered, but I will not be talking about that one today. I think we can jump directly to the next slide, where we very shortly show the cross-border issues and the solutions, or the features considered as solutions in 5G-MOBIX. I also don't want to spend much time here, but I do want to say that, of course, for us, and I think for the entire 3 projects involved here today, the focus really is on what happens when transitioning from one country to the other. How can we make sure that the network can continue to support the CAM applications at this moment where we really have to transition from one network to the other, which of course is quite a critical moment for communications. Maybe we can already jump to the next slide then. And here I have tried to look at some very practical issues that we faced and some lessons that we've taken away from our deployments. And I've sort of structured them into 3 groups here. So components and features, deployment and integration, and then sort of what comes towards the verification and testing. And I apologize that those slides are a little bit of text, or they're actually rather text heavy. I will not read out everything. I know that you can read much faster than I can speak, so I will only focus on the key points here. And if it comes to components and features, I think the first key point here to make is that yes, there was a lot of promise on what would be available and what is sort of the timelines, but when actually putting these things out in the field, or even trying to get them in order to put them out in the field, we saw that many things were either not available, not quite as ready as they were supposed to be. And especially when looking towards deploying SA networks and getting chipsets and devices for SA networks, that was an issue we repeatedly faced to see that either features are not yet ready, or there's incompatibility between features on the device and network sides. And of course, that then meant a lot of repeated cycles for integration and eventually for testing, not even for trialing, of course. So that is definitely a lesson learned, that the availability was not as it was progressed, or not as the timelines would have suggested maybe. So that is certainly something to keep in mind whenever you're trying to actually test a relatively advanced use case like a CAM use case on a network or on hardware that is not yet to the point where you might want it to be for integration and trial. Something that stayed with us until today, until we actually start trialing now, is the stability and the compatibility between things is still an issue. And I think this is definitely something where it's also a pointer towards the industry, that the stability and compatibility between chipsets, and especially again for SA, is certainly not yet good enough to achieve the reliability that we would want or need for CAM use cases. And then on the right-hand side, you see firm and software support are critical. I think I said this already. Maybe the point to make here is that there is plenty of upgrades and updates coming out, features and bug fixes, but there is still too many things that are maybe lacking, or small incompatibilities that just hamper performance to the point where it's not where we would want to be. Support for SA remains limited. I think that is not a surprise on one hand, since the focus certainly was on getting NSA up and running, but there's many promises that only really can be fulfilled with SA, and I think there's also still many points to be made to get SA to the point where it's stable and sufficiently workable. Also, the regional differences between SA support, even in commercial devices, is something that is not necessarily obvious, and certainly can cause issues when relying on those devices. One point that I think was already made by Fikret, that there is quite a bit of difference between having a commercial device or doing an integration yourself with just a chipset into an OBU. But sort of that's the selection of issues we faced. I don't think there's anything super surprising in this set of issues. And maybe the lessons learned really is that planning is key here, and also making sure that planning in a high level of detail and with maybe some buffers in the timeline is the key here. Maybe then we can go to the next slide, where we look at the deployment and the integration. And I think here, then there's a few more technical challenges that come in, or maybe the first one, actually, spectrum availability and assignment is as much a technical as a logistical challenge. But here we saw that, of course, when we start with test licenses and we move to commercial licenses, this can cause reworks, etc. Looking at spectrum availability on the LTE side for NSA mode certainly was an issue to be considered, especially when separating things out for exclusive testing for the CAM use cases. What we observed was the complexity of configuration of the networks definitely grows in SA mode. I think there's quite a few new characteristics and issues that arise. And maybe what we also faced was that the support from the ecosystem is not quite where it is for NSA. Yeah? There's less experience out in the entire ecosystem, the same way there's less experience with SA inside the project and the consortia, of course, themselves also. Similarly, some of the considerations towards PLMN IDs, we saw that the scarcity of PLMN IDs tends to grow as we have more private networks coming up, so PLMN IDs are even more sought after. And I think seeing also that some modems and devices might not support the test PLMN IDs commonly used for the kind of project trials that we have also didn't necessarily make life any easier, of course. Then on the right-hand side, again, we have some restrictions on TDD frame structure. I think that is one where I have a special slide towards the end. So there's restrictions on what we can do, especially if we have to collaborate cross-border and synchronize cross-border. That definitely raises challenges here. And I think it very much limits the ability and the freedom to increase uplink capacity, which, of course, for some of the CCAM use cases is quite important. And the last 2 points here on this slide basically are sort of on making sure that the planning doesn't only take into account the radio, but also considers the fixed links and sort of the logical policies. If I hook something up that was made for testing with the commercial network, of course, there's always limits going to come in there. And then on the virtualized components and network, I think considering how to interconnect them and how to manage their connectivity is quite key. They seem to be simpler to deploy, but that's not necessarily true once we have to make sure that they can all be interconnected. Then maybe we can proceed to the last block here on verification and testing. I think on verification and testing, there shouldn't be too many surprises, but I think there's quite a few key points here. The first one is, maybe we can stay on the testing slide, is that we basically have very high, very stringent synchronization requirements, both for the operation of the network, but of course, even more if you want to test the very low latency levels that are required by CCAM and of course promised by 5G. Reliability and performance, I think I said enough about, and also readiness for testing and the complexity of testing. I think you can imagine that with the CAM use cases and testing across a border, of course, this is much more complex. And that's also something mentioned then on the right-hand side with the cross-border corridor and the multi-PLMN test and measurement is definitely a big challenge to make sure that everything is synchronized, but also that all the data is there, that the controlling of the handover point actually is a complete topic in itself. Should it be controlled? How can we determine it, etc.? If you have a restricted area where you can do your testing, you have to make sure that your handover can happen reliably in this area. That's also quite a problem. On the right-hand side, on the top, we see quality of service measurements with only CCAM traffic, of course, is an issue, and realistic loading of 5G cells with many users and heavy traffic, of course, at this moment is still tricky. Maybe we can jump to the next slide. I have selected two specific technical topics, which I think might be of interest. I will only very briefly touch them here. So there might be an interest for questions, of course, to be asked. Those ones I think we can have to the end of the webinar. And maybe if there's interest from your side, feel free to either take the contact or can we go back to the roaming slide? Sorry. Maybe if there's interest, we can certainly also have further discussions on these, I suppose. And there's deliverables upcoming from 5G-MOBIX on those topics. So the first one that I've taken here is seamless roaming. How do we make sure that we get rid of this disconnect when we're crossing a border, which at the moment will be on a minute scale? And I think we've come sort of to the conclusion that the preferred way would be to use the N14 interface to basically do an inter-PLMN handover. And of course, then there's many things that come with this. There's some data exchange required between networks. There's some information that needs to be passed to the UE. And then on the right-hand side, you see that not only are there technical challenges to actually make it happen, but also once we want to scale it across the entire continent with countries, etc., in Europe being quite small, then it also really becomes a scalability issue where all of a sudden you have 1,000 PLMN combinations, which might be your next, and of course it becomes very hard to figure out what to do about this. And there's a couple of steps on the bottom right that I leave to you to visit yourselves. But there is both things that need to be done in terms of regulations for data sharing, but also technical issues, and then maybe some research still required. Then we can come to the next slide where we see the TDD selection and synchronization issue. I think I mentioned this before in the deployment issues that we face. Basically, there is restrictions that come into place because with TDD you might have interference on a much stronger level between adjacent base stations, etc. So there are already recommendations out there, of course, from ECC regarding the available and the suitable frame structures. The need for a common phase clock reference, I think, is relatively well understood. But what we have observed, and I think this is maybe the more interesting part here on the bottom right, is that if you can follow these or you can use separate bands, the performance impact actually is not significant. So that is, of course, good news, but you will have to live with the restrictions that come from following only those frame structures. And again, for us testing our CAM use cases, this was mainly on how much can we boost the uplink data rates. But there is, of course, then the hope and the expectation that with downlink blanking and crosslink interference cancellation that should come in the future, this could and should be improved. With that, I think I can come to the last slide where I mention a few further recommendations. I would actually leave those for your own enjoyment. I think the point is that there are many things that still need to happen in order to make the technology fully viable. And then there is many things that need to happen around in order to actually make it viable to have these deployed along our highways, along our big traffic arteries. And of course, that is both regulatory, logistical, and financial business issues that need to be put in place here. So I wanted to mention those further recommendations before coming to the conclusion that I think there are many challenges that we faced, many interesting lessons that we learned. I'm sure there would be more that we can share. Once again, there's a deliverable coming up on this, and I think in Fikret's slide, you found the link to the deliverables of 5G-MOBIX. And I would invite you to follow this space, follow the deliverables, and certainly get in touch if there's any questions beyond the question session, of course, at the end of today's webinar. With that, thank you very much, and I hope that this gave you an insight on what we have been doing in MOBIX.
Thank you so much, Simon. Dirk, the floor is all yours.
Hello, good morning, everybody. I will here present first results from our 5G GROKO piloting. I made this presentation together with Maciek from Ericsson, and let's jump to the next slide, please. In the project itself, we have 3 big use cases: teleoperation, anticipated correlated collision control, ACA, and map update. And I will here in my presentation take a very small example, and this is our ACA use case to show how we performed our piloting and what are, let's say, important lessons learned and how we tackled the different issues. So I will give you a very short background for this use case, and then I will go in very few details for this test and trial executions and analyze. Next, please. In our piloting or in our project, we have very strictly differentiation between test and trials. So our plan was, and of course we also performed this, to start with so-called small test environments to perform tests for different components. Of course, at the end, with all components, but not to put all this together right from the beginning. And so we have been able to check issues in smaller environments in before. And later in the second step, we jumped then to our trial environment. And in the trial, especially in the Schengen area and in the, let's say, real cross-border constellation, we then made the measurement to perform the tests for the KPIs, and had an let's say possibility also under Corona conditions to perform the test in, let's say, quite short time periods. But it was tricky, and again, I can also recommend very strongly to start with these small pieces and then to grow up and to have the full test set up at the later steps. And we also had 2 test periods. That means we started 2020 with the first round, and then we improved our constellations and our setup and have done the same, or more or less nearly the same test again this year. Next slide, please. The test case I will explain here a little bit more in detail is our ACA use case with different user stories. We have broken down cars, and they are reported to the backend in different constellations. And of course, the related feedback then as a car message is then to be distributed to the fleet. And so we have a very clear loop with this constellation. Next slide, please. That means we have one car with a detection of such an issue, to have a hazard report coming, in our case here, from a fleet from Renault, transmitting this to a backend and then distributing this information to over different other channels, then messages or JSON with MQTT for different fleets. And the question here was how to come to such a very clear evaluation to get an availability for over 99%. And we evaluated then different parts of this use case or these user stories. Next slide, please. That means we checked different connections, and we have then very clear KPI requirements evaluated in before, of course, what it means, how often we have then to check, and at which time this is really measured as failure or not. And then next slide, please. We took this evaluation over these different connections. It means a connection coming from sourcing cars and then going to the different other cars. And of course, we had then to repeat these measurements in these different constellations. Next slide, please. And for our KPI requirements, we have the different questions to answer. That means with an reliability over 99%, question will raise how many of these hazard reports we need to determine for the KPI. Then, of course, how long this will take and how we can speed it up. Now, please, next slide. And to come to real good results, we have really many events to calculate. Here you see that we need more than 100,000 measurements, and this is of course a quite long test period, but with smaller numbers you cannot really give this stability according to application level reliability, according to this SLA. And this is, of course, possible to speed up, but at the end, you cannot deal with hundreds of cars. We have to use a number of cars we can use for the trial, and so there are, of course, limitations to speed up the measurement in, let's say, in very large scale. Next slide, please. For the calculation of results, we have, of course, then to look on the dedicated values, and we have some, let's say, learnings. That means for these measurements, we know that the exponential distribution models will work quite well, but especially in this very complex environment, you have normally unintended correlations from different other, let's say, influences. You have TGI slot boundaries, you have TDD frame durations, and all this, and of course other influences from network will lead to different pictures, and you have to explain on which point you will do measurements and see things like designed, or if you have other influences coming from your use cases. And of course, you have also points in the network like control plane issues or overload issues in the network. In our case, it was quite easy to handle because we have this dedicated network for CROCO, this 5G networks. But of course, it's a total other issue or constellation if you will go in real, let's say, production network environments. Next slide, please. Next point is for statistic test. You have to see that you will start with static test environments to have perfect radio conditions before you will go for drive testing. We already heard such issues like internal or external antennas, and so we started always with ping and IP perf test for preparation, and then we repeat the experience with many changing parameters to really come to strong and stable results for our measurements. And of course, this is a very big part then of our work, and all this can be see in the delivery D41 and D42, how such KPIs will be influenced by different aspects. Next slide, please. The next important point is that we have also to look for very critical for our results, and to make plausibility checks for, as an example here, for maximums or minimum, so that you have always a critical result. There is a need of a critical result discussion to check if different outliers, for instance, will really be or can escape or delete it to get, let's say, quite proper information out of this test periods. Please go for next slide. Yeah, here is only a very short example how this may look like, and then you will come to this plausibility check that you have to see how confidence intervals will work. Next slide, please. We defined for our results that the confidence interval below 10 is quite okay. And so we have to check how this will be reachable in our test environments. And we had really the constellation that many things took much more time that we expected, especially in the real world environments. And it means our, let's say, good feeling is on this side, take 3 times more what you have calculated for your test performance. That means if you think that you only need 1 day for measurements, take 3, and then you will come to a quite good time frame for this real world environments. And as you already know, to jump for the next slide, especially in this test environments, many things can go wrong. Sorry, next slide, please. And all things, if they will go wrong, then they go wrong. And so this is a very important part, of course, to have this buffer to deal with these problems, what will maybe happen in your test environments. And of course, again, all this information are available publicly on the 5G COCO webpage. Thank you.
Thank you, Dirk. And now we move on to the last speaker, Edwin.
Yeah, thanks very much for having me today. I'm now talking about 5G Carmen, and I called it Notes from the Field. We just had our last interim review, and we are in the middle of still doing integration testing, and I just would like to share with you a couple of experiences so far, but also give you a very brief overview as a short recap of what we are doing here. Next slide, please. So the first message is, of course, like I'm not suggesting that we go through this slide in detail, but my key message is like if you go for a 5G for CAM deployment cross-border, whatever approach you take, it will be very complex. That's for sure. You have the vehicle layer with the devices, of course. You have a network layer. You have the distributed edge cloud inside the networks. Distributed edge cloud, also sometimes referred to as multi-access edge computing. You have some orchestration functions, and then you have on top also some say nodes or systems which need to be integrated, be it CITS backend systems or some of the currently a bit more of over the top things like precise positioning, which is important for maneuvering use cases, or the prediction of quality of service in a network, something which still is early stage, but nevertheless it's fair putting this to the test. And that means like, okay, you have a huge and significant integration effort for combining everything. And this is like, we have 25 partners, and our corridor is Munich to Bologna. So we talk about 600 kilometers, but of course we only focus on the borders, and specifically the 2 borders between Austria and Germany, and Austria and Italy. Yeah, so it doesn't make much sense having extensive in-country pilot sites and stuff, because the most interesting thing is definitely happening at the borders, where you not only have to think about switching from one network to the other, but also then switching the application/service context from one edge cloud or distributed edge cloud to the other, back and forth. And that is really interesting. And if you do it with multiple vehicles, of course, not all vehicles will be on the same network at the same time, but they are also driving in proximity. They are in different settings, in different service environments, and you have to make these interoperable and working. And so that's something which must not be underestimated in terms of what is the effort for putting this in place and then for putting it to the test. So that is my first message here. Next slide, please. So we chose implementing in commercial networks, yeah, and this has, of course, its pros and cons overall. At the current stage, 5G NSI is really the common denominator for commercial networks. It's like you can see some early stage standalone deployments overall, but in terms of if you would like to make it work and do the interoperability thing, then first thing would be like between 5G NSI networks. At least that is what we've chosen with the 3 network partners in Germany, Austria, and in Italy. The 5G NSI for us was a common denominator, yeah, and even where we were confronted with different deployment stages overall, which is okay, but it's very natural, but it has its implications. For us, we determined like it is still too early for 5G standalone, and especially when thinking about 5G standalone cross-border, yeah, we see now first standalone networks popping up and not necessarily being deployed at borders, yeah. So and when making it work cross-border for standalone, I would say, well, we concentrate on the NSA part, and probably you will automatically come to the similar issues with regards to, say, 5G standalone. While 5G standalone will certainly bring you some advantages with regards to handover capabilities, but also reselecting your endpoints basically in the network, because when changing from one border or at the border from one network to the other, at the current stage in commercial networks, everything is still based on home routing, right? So that is certainly something which does not play well in combination with multi-access edge computing, where you would like to have the service execution happening at the in proximity of the roads, of the transportation corridors with the vehicles. So in such regard, you need to relocate the anchor, and in this regard, the path to the closest MAC possibly. So that's stuff which certainly needs to be implemented, and it can be tweaked. You can use NSI settings and use 4G and relocate the packet gateway to the closest MAC and the visited network. That's all possible, but it is, say, certainly not off the shelf when it comes to commercial networks. So you have to implant something which is probably still too early for being fully commercialized, but it is in principle possible, and you need to make it work in a commercial network environment without jeopardizing commercial network operations. So that's really a difficult thing. Of course, commercial networks offer the advantage of, in at least in theory, you could have a wider 5G NR coverage. So in the NSA setting, compared to bespoke but geographically limited networks. Yeah, you can have your project network, your overlay network, cross-border with a handful of sites on both sides of the border, which could be sufficient, that's for sure. But ideally, of course, when going for a commercial network, it would be very nice profiting from say, wide area coverage, not just limited to a few kilometers back and forth across the border or along the border, basically. So, but it could have its limitations. And from a 5G calming point of view, well, we see like, well, we do not benefit too much from this potentially higher or larger NSI coverage, because not necessarily the coverage is in the frequency bands which is supported by the device or the devices you've chosen. In our case, we have from one partner, we have one device which is kind of automotive grade, but it only supports the 3.x gigahertz bands when it comes to 5G NR. So we do not benefit from deployment of NR in, let's call it legacy bands, like the B1/N1 band, the 2.1 gigahertz band previously used for 3G. So that has also, it has its pros and cons, and it does not necessarily help. Yeah. So we have experience with having 5G NR coverage at the border is really, it is really like, I would call it bleeding edge. Yeah. So it's nobody is deploying commercially like right from the start at the border. So once you start moving your commercial network colleagues and persuade them to deploy at the border, you run into all these cross-border coordination things, which are still on avoiding interference to some degree, yeah. But it is not yet a common practice, especially when you look at 5G NR in the TDD bands, with all the issues already highlighted by my colleagues from 5G-MOBIX. But our experience is like, well, you have a mismatch of the TDD patterns. You even could have a mismatch of the timing offset of these patterns. For example, between Austria and Italy, they are both on the same pattern, the eight downlink and 2 uplink symbols, basically, but they have an offset of 1 millisecond because one is using some WiMAX-based legacy, which needs to be protected, some countries, I would say, and the other is using an LTE-based one. And obviously, they are on a different time offset. So this is stuff you experience once you deploy stuff, and that's an interesting experience. And of course, we will further include and propagate the lessons learned here. The other thing also already mentioned is like commercial networks, at least off the shelf, do not support cross-border service continuity. And in a commercial network environment, you have to find out what is possible. So we've chosen to start with equivalent PLMN, which helps the device to select, say, the other network in the border or in the cross-border area. We also will play around with fast network reselection parameters to support some release and redirect. Yeah, but the point is, like, you cannot, or it will be very difficult to introduce new interfaces like the S10 interface in the case of 5G NSA for supporting network guided handovers, and especially through seamless handover. So that's stuff which is really, really difficult, and it has not only technical limitations and implications, but also regulatory and finally also commercial implications. And from a regulatory point of view, well, in some areas or in some countries, you might be forced to stop a service, or at least provide a trigger point. I'm naming things like lawful interception, for example, which could have its say here. So it's kind of a challenging factor as well. Next slide, please. So everything related to integration, testing, and piloting, that was also already mentioned by my 5G Croco colleague. It requires a lot of time and certainly more than originally planned. I would definitely recommend, from our experience, we are still in the middle of, say, doing integration testing and ironing out a couple of bugs. First thing is, like, go for a layered approach for testing. Connectivity first. You will stumble across so many issues with regards to connectivity, not only across different networks, but also Wi-Fi devices. If you have multiple devices or different devices from different vendors, you will experience some different behavior. That's for sure. Even if you have just one device, as in our case, you will see differences. And I can also just resonate what the colleagues from 5G-MOBIX said. Like, we have one car OEM who is using the device really with the rooftop antenna mount, basically in the same device. In the case of our second car OEM, it is used inside the vehicle because the antenna and the device itself are really kind of glued together. Yeah, you cannot place them separated and just lay some wires and stuff. No, it's quite tightly integrated. And of course, the attenuation inside the vehicle versus having the antenna outside the vehicle and the modem mounted just underneath the antenna, but inside the vehicle, that definitely makes a difference. The other thing is, like, integrating and testing applications and services should come second. Yeah, whatever you can do in terms of client service setting and stuff, test it separately, and then everything integrated in the vehicle in a full package with vehicles driving around. You have multiple people who are needed per vehicle to, first of all, drive, but also to do measurements and setups and stuff inside the vehicle. You will keep a couple of people busy when driving around, and then just discovering connectivity issues or still some application service setting issues. This is costing a lot of time, and you might a bit say, it's a kind of a bore out risk you might have, especially with the people who are sitting in the vehicles and having to wait for networks or any partner being in charge of an application or service to fix something before they can continue the test drive. So go for a layered approach. That would definitely be my recommendation here from what we've experienced so far. And do not attempt doing everything at the same time or all combined. Yeah, it's definitely a risk of wasting time and effort. The interoperability and configuration issues are really significant. It has to do with the different networks and settings, with the SIM cards, with all bespoke settings you've met. I've mentioned equivalent PLM. And when you ship, for example, a new batch of SIM cards, well, don't forget to also configure equivalent PLM and for this new bunch of SIM cards. Otherwise, the testing will just fail. Yeah, too many faults, too many missed KPIs. And as my 5G Croco colleague has correctly stated, for collecting KPIs, you need to do many test rounds and create many samples in order to have a statistical significance. Yeah, that's really important. And last but not least, testing 5G CAM or CCAM services on public roads remains a challenge. We are doing in 5G Common, we are doing maneuvering services, yeah, with inline and lane change maneuvers. And doing this in live traffic is also challenging and could have an impact on the number of test rounds required, because you always have interfering non-connected traffic basically, and you cannot really block the roads, especially not a motorway such as the road arteria from Munich to Bologna, which is one of the most frequently used transportation arterias across Europe. So that would be my final recommendation here. And on the last slide, just some words to cheer you up. So next slide, please. So it is absolutely important to have some perseverance here. Everyone needs to be a bit stubborn and continues pressing ahead. It's really important, because not everything envisaged will work as expected. Yeah, and what we've seen, like 5G is definitely required for demanding use cases, like the maneuvering in a level 4 ready environment, basically for others level 4. 5G is indispensable, that's for sure, but 5G NSI still has its limitations, but we see the trajectory is right, so that's really important. What also is important with all these kind of projects, finding out what worked and why, and especially what did not work and why it didn't work is as important, and it provides valuable information to everyone who is trying to put CCAM into reality. And by this, I would end my talk. Thank you.
Thank you so much, Edwin, and thank you so much all. I could already see some questions coming in, so give me 1 second to find them again. All right. A question from Maxime to Fikret. When you mention RSA maintenance, are you referring to roadside units? Fikret?
Yeah, roadside units, first of all, refers to roadside infrastructure, first of all, refers to roadside units, but there may be additional infrastructure elements like sensors, traffic cameras, or far edge computing units, which may be co-located with the roadside units, the RSUs. So RSI in general, the roadside infrastructure may refer to RSUs plus a collection of other sensors and other entities. As a matter of fact, here in our German trial site in Berlin, we also have, besides traffic cameras, parking sensors, road condition sensors, weather sensors, etc., deployed through a certain road segment at the center of Berlin. But these are not in the context of 5G-MOBIX. The trial site was developed also in nationally funded projects in Germany. So we have here the infrastructure digitalization to the real sense, kind of like a smart city infrastructure, where we then also get additional insights, additional data related to mobility in general. Sevi?
Yes, thank you, Fikret.
And maybe to add here, this is Edwin. Maybe to add here, as Fikret has pointed out, it's like roadside infrastructure could also be virtualized roadside infrastructure. So components sitting in an edge cloud environment, for example, and it doesn't need to be in absolutely close proximity to the road, but you could have virtualized RSU type of functionality or data fusion and stuff. And that might be sitting on a Mac environment, which is also subject to maintenance cycles, updates, and so on and so on. And when we come back to the multi-country, multi-operator deployment issues, since the platforms are not the same, they are not harmonized in such regard. And this presents, and it was, I believe, Fikret or Simon stated, this is also challenging to the entity providing the service running on, for example, on an edge cloud environment. Yeah, it's like you have to deal with different, approaches, be it containerized, be it Docker, be it whatsoever, Kubernetes clusters, and so on and so on. And doing these adaptations, we do it in our environment. Is a confined environment, but thinking about scalability and extrapolating this to, say, wider Europe at the end, of course, that could certainly and will certainly present a challenge. Yeah.
Thank you, Edwin. I will move to the next question. Can you confirm on which 3GPP release you were working? I think that is addressed to Simon.
Yeah, I think that's a tricky question. I think since the projects already are some time old, I think at least initially everything was based on RHEL 15. I think a few of the things that at least some of the trial sites have done brought in parts of things from RHEL 16, but I wouldn't be able to say that specifically all the trial sites are specifically working on one release. I think there is a certain amount of fluidity in between.
Yeah.
Yes.
That also applies to the other projects. Yeah.
All right. Shall I move on to the next question? This is from Andreas. What kind of RAN data sharing approaches do you evaluate? Who would like to take this question?
I'm not taking it because Andreas was our previous technical manager, so in 5G Carmen. So it's more related to the colleagues from 5G-MOBIX and 5G Croco.
All right. Any takers?
For the Croco, we have let's say our own testnet for 5G, and there is no sharing approach on the RAN.
Then I guess the question will rest with me. I think it's a difficult question to answer shortly. I think we mentioned quite a few things and quite a few bits of data that would have to be shared, and I think that was mostly for the seamless handover. I'm not sure we're ready to say that there's any specific approach that we want to recommend. So I would maybe ask that we delay this question until we have some more things to share on this.
All right, thank you so much. And I move on to the last question. Whilst these 3 projects have done excellent work, there still appears to be much more work to be done. Do you believe additional funding is required to support this? And should this funding be seen at an R&D level or an implementation level?
I think this question will go to all of our projects. For the cocoa, I would say, okay, we have more or less on a good way to fulfill the questions for the research activities in our project time. So I am expecting more deployment funding for the future.
Edwin?
Yeah, well, pre-deployment, deployment. For the time being, I would not expect really R&D level, at least for most of the aspects. Well, when it comes to best practice, like Andreas flagged, the around data sharing principles and approaches. Well, there could be some kind of more R&D type funding could be necessary, but ultimately, I believe it is really like more. First of all, in parallel, we have the ICT 53 core projects and beyond. So passing on, say, our insights and what we've seen, what we've witnessed, passing it on to the others in terms of, yeah, having them doing for further study is certainly one of the approaches. I would not necessarily say like, well, let's kick off yet another activity which goes bespoke into some of the aspects we've seen so far. So I believe there is a reasonable transfer and call it handover to subsequent projects, which are probably building upon, in an incremental approach, building upon what the ICT 18 projects have been digging up, basically. Fikret.
Yeah, thanks, Edwin. Yeah, I wanted to also add that this is actually a good point, the correct observation that we have done a lot in terms of the rollouts, in terms of deploying all these components at many locations for 5G for CCAM testing. But there is indeed, as noted out, there's indeed a lot still to be done, especially in terms of the trialing and evaluations. And getting insights out of those, feeding them into standardization, etc. And we should also highlight that we worked more or less throughout the whole pandemic area at the time, where we had closures, lockdowns, inability to access physically our test locations at certain times. Therefore, at least for the 5G-MOBIX case, there has been 9 months so far, 9-month extension of the project's running time. Currently, we are going until end of July 22. And yeah, we are putting extra effort basically to try to still cover up the readjustments that were necessary, dealing with many complexities that we were not able to foresee from the beginning. So yeah, I think I agree with my colleagues that most of the additional effort and funding would be more the practical things, more implementation, more development than research, I would say. But in the end, it's always a combination of both, because 5G standardization and 5G research and beyond 5G research is also ongoing. So there should be an alignment in any case with the implementations.
And to some degree, it will probably also be covered by the Connecting Europe Facility 2 push for 5G for CAM on corridors, on transportation corridors, which also includes some inception studies. So towards, say, deployment-related aspects. So not so much R&D, but more pre-deployment deployment. So there would be an opportunity as well to to set a common ground for basically for rollout of 5G based CCAM services. At least I reckon.
Yeah, I tend to agree. I don't think there's much more to add here. Maybe, as you pointed out already, there could be specific topics where some research is needed, but I think the majority of what is now needed is really towards deployment, and I guess also towards figuring out how on a commercial basis this would make sense.
All right, thank you. I can see more questions coming in. I will take one more question from Guillermo. How was the support to deploy your own Docker images in commercial infrastructures? Meaning if, for example, the K8s were only accessible by the orchestrator, did you have to, sorry, the question is being cut. Did you have to connect private registries? Edwin, would you like to take this one?
Probably I'm not the right person to tackle this question. I'm not certainly, this is not my area of expertise.
All right. Any takers? Fikret, perhaps you?
Maybe it's best if we take this offline. We have, I mean, this goes into the technical details. There are different approaches used at different trial sites. You have our contacts, so we would be happy to take this offline.
Fair enough. And because more questions are also coming in, I will be sending those questions to the speakers so they can address it. They can reach to you with their answers. So I would like to, if I may, I would like to conclude with this last question. But before we go, just a quick note that after this webinar, you will be receiving a follow-up email with a survey link where we'll be asking for your input, your proposals on other subtopics or other topics with regards to deployment and integration issues. What would you like to see in a future webinar, in a future discussion? So please fill it in so we can have your input and move on accordingly. Yes, and I would like to thank you all for attending. Many thanks to the speakers for the great presentations, and yeah, for me, I'm wishing you a lovely weekend.
Thank you
for having us.